TensorFlow module, right? So it's a library module which you have to install in either Python, Java, or mobile for IoT, right? So immediately if you go to the website that I've given to you, you can go quickly to get started with TensorFlow, and then you can click on see tutorials. All right. Okay. So later on you can go and see the guide, right? But for a quick look into uh, what TensorFlow can actually do, so we can immediately look at the tutorial. All right. So for the tutorial, you have earlier on you have two quick start for beginners, and the other one is for expert. All right. But I don't want to go through that. Right. It's not that interesting. So I want you to go to this one that I've already shown you in the Telegram. Okay. If you uh, done this correctly, right? So you should have under the beginner menu under machine learning basics with Keras, right? So you have basic image classification. So click kat sini, basic image classification. So you will have this example, right? Basic classification, classify image of clothing. So you can immediately download the notebook. So I believe you have already learned Python in DSC, right? DSC 550. Okay.
Yes.
Okay. So you should know how to run the IPython notebook, right? Betul tak? Okay.
Betul, sir.
Right. So if you have already downloaded this, right? So the example is pretty straightforward. Either you can download the IPython notebook, or you can copy the code sample from here and paste it in your own IPython notebook. Alright, so I have with me a pre-downloaded example. Alright, so let me check first. Mine should be this one. Okay, let me share this. Alright, so it's the same example, but with a little bit of tweaking lah. Alright, so I've already run this in previous classes, so let me restart first. Okay. Alright, so basically what I'm going to show you today is how to make use of TensorFlow. Okay. And with TensorFlow, you are doing something like you are creating a machine learning model similar to using tools. Alright, so basically TensorFlow is like a tool lah. So you don't have to create your own machine learning from scratch. Alright, so you don't have to create your machine learning from scratch. Let me see. So what you can do is just immediately load the necessary libraries, and from there you work out how to manage your data first, and then you feed your data to the created models, right? So today I'm going to show you how to do that, right? So previously we had a little fun on creating our own back propagation algorithm, so I'll pass on that for a while, so I don't want you to get confused. So it's better for me to show you how to use TensorFlow as it is, right? So today we'll go through TensorFlow, right? So basically, here is the downloaded sample IPython notebook, and at the first cell here, okay, it says that you need these modules, right? So you need these modules or libraries in order for you to be able to run this example. So the first one is you need TensorFlow. Okay, and then Keras, right? And then the next one would be NumPy and Matplot library, right? So NumPy and Matplot library is for calculation, all right? Uh, Matplot library is for uh, displaying graph and all right? So if you manage to run this example, the first one, the first cell, it will print out the version, right? The version of your current TensorFlow, right? Not the version of Python that you are using. Currently using Python 3, but my TensorFlow is version 2.3.1. The from the website, it says here the latest one is 2.4.1. Okay, but I think 2.3.1 is not that far off from the latest updates version. So I think mine should work fine, right? So before we continue with the example here, we need to understand what are we going to go through, all right? So first of all, we are going to look into the fashion MNIST dataset. So previously, I've already shown you my sample example dataset is on numbers, right? So if you remember correctly, from my previous meetings with you all, I have an example of apa tu of my sample is numbering kan, betul tak? Sekejap, nak terbersin pula. Sorry eh. Asyik saya sempat tutup mic. Okay, previously I've shown you an example of classification of numbers. Kalau you ingat lagi lah sebelum cuti raya tu, dia pun tak beraya sangat kan, betul tak? Duduk rumah je kan, is it? So it shouldn't apa tu you shouldn't forget lah, kan, betul tak? Last week kita belajar apa? Last week pula, sebelum raya kita belajar apa? Classification of numbers kan, kalau you ingat lagi lah, right?
Also, DJ classification.
Okay, so for the number classification, how many classes do we have? Berapa
10.
banyak? Yes, 10 class. We have 10 class of numbers from 0 to 9, kan? Betul tak?
Yes, sir.
Okay. If you look up into the internet kan, you Google up, okay, Google MNIST, you should have the same example, a number, samples of number from 0 to 9, but the complexity of the resolution is a bit higher. So previously when I show you that my examples is the pixels is 5 times 7 pixels. Tetapi on your case, sorry, on MNIST, okay, the MNIST example is 28 pixels times 28 pixels. So you have around, sekejap saya kira pakai calculator, 28 times 28, around 784 pixels, right? Okay, so similar to that MNIST sample, okay, nowadays sebab MNIST sample tu dia terlalu common sangat, dah lama dah, more than 20 years, right? So they introduce a new dataset, which is the fashion MNIST dataset, but it is quite similar to the MNIST one, right? Just to show that you can actually create other samples of dataset that follows the same format of the MNIST dataset. Format dia sama je, which is 28 times 28 pixels for each images that consisted of 20,000 grayscale image in 10 category. So MNIST number tu dia 70,000 grayscale image. Kategori dia sama, 10 juga. And the resolution is also the same, which is 28 by 28 pixels. Alright, so these are the example lah. Okay, you have an image of clothing, okay, in 10 category. Alright, so I've already run the first cell here. So now the next step is to run or to load up the sample. Alright, so dalam Keras, okay, inside Keras, we have a preloaded example of dataset. Alright, so the dataset is preloaded, and um, you don't have to download the dataset from the website, and then you have to load up again using Python. No, you don't have to, right? Because everything is readily made available, right? And you can immediately use the dataset from the Keras library, right? So this is because we have already preloaded Keras on top here, kan? Kita dah load dah from TensorFlow, import Keras, and then here down here we just use Keras module dot dataset dot fashion MNIST. So automatically fashion MNIST will be preloaded into this object, right? Fashion MNIST akan jadi object dataset dia lah. Okay, and then the object has a predefined module called load data. So the load data will pair up two different variable, which is train images and test images, which is paired with train label and test label. And both train image and test images is consisted of 60,000 and 10,000 respectively. So sama je macam MNIST dataset. So later you boleh investigate lah macam mana how the MNIST dataset is distributed in order to do some sort of training, right? Kalau you nak tahu lebih lanjut, you pergi kat Google kan, lepas tu you type MNIST dataset ni, so dia keluar ni. So Yan Li Chan is a Chinese descendant born in America, right? So he's a professor, I think on ni professor in NYU. So he is the one that developed the MNIST database ni lah. So MNIST database dia cakap dah has a training set of 60,000 example and a test set of 10,000 example. So sama lah 70,000. So the MNIST dataset is 28 times 28 pixels. And if you Google up yang lain kan, so kalau saya Google MNIST contohnya Chinese, MNIST Chinese, so dia ada, see kat Kaggle kita ada MNIST Chinese character. So the format should be of the same value. Kalau saya klik lagi dekat Kaggle ni, dia kata ni, see, nampak tak? Format dia sama je. Format dia akan jadi 28 times 28 kali 28 pixels, and then let me see. Mana nak tengok ni? Sekejap ni how to load. Tak. So data, klik kat sini. Ni. So dia kata kat sini 100 national, Chinese national. So ada 15 numbers. Alright. So resolution dia lain sikit lah. Resolution dia ni adalah 300 times 300 pixels. And then the number of sample is 15,000. Right. So 15,000 sample. And then you have to do some sort of processing lah. Dia kata the dataset contain the following. Size dia dah reduce kepada 64 times 64. So again, in order for you to do the same processing, so you need to reduce the size lah. Reduce the size of the image to 28 times 28 pixels, right? So nanti later dalam chapter processing nanti saya explain lagi, right? Okay, let's go back to the exercise. So load data. So saya load je. So now the data is loaded, right? So yang bawah ni tak ada benda, ni saya tambah untuk kalau dataset tu number lah, nanti later I show you tomorrow. Okay. Okay. So next. Okay. When we have only loaded the dataset, the labels are represented using numbers, right? From 0 to 9. Okay. So we have to actually create the class label using the text lah, string. Text string ni kita yang create sendiri. So this is why here is an example of class label lah. Supposedly the second one is trouser, so I change to seluar because I want to show you that it is possible for us to create our own class label. Yeah, because the original class label that we have already loaded in the test label dengan train label ni dengan test label ni, nilai dia dalam numerical value ni lah, from 0 to 9. Okay, can anybody guess or tell me why the label created in numbers? Kenapa hilang? Tak apa, kita tengok nanti boleh jadi. Soalan saya, kenapa label ni dia buat dalam bentuk number tapi dia bukan dalam bentuk text? Siapa boleh bagi tahu?
It uses one hot encoding.
Okay, okay, betul lah tu. So because later we want to convert to one hot encoding, or if not, we have already learned kan, that dalam backpropagation algorithm kita learn there's 4 process or 4 steps, right? So step number 1 is initialization, step number 2 is activation, step number 3 is weight training, and number 4 is iteration, right? So during weight training you have to calculate the error, kan? Betul tak? So in order for you to calculate the error, the network can only produce the output as a numerical value. Jadi tak boleh produce output tu dalam bentuk string. Okay, so that's the reason why the label are already predefined as numbers, right? So dia tak define label dia as string lah. Okay, otherwise nanti later you kena define as your own number juga. Eventually if you want to create your own model lah. Okay, kalau label dia dalam bentuk teks ni, there's a lot of possibility later dia akan jadi susah sebab handle ni boleh jadi typo, okay, boleh jadi a misinterpretation of classes, right? So kalau dia bubuh number sahaja, it's very clear, and the chance of getting mislabel is lower lah. Okay, right. So supposedly by now you should understand kenapa what is the implication if the labels are in a string or textual format, or the labels are already in numbers, right? So tak salah pun kalau you nak labelkan dalam bentuk text, tapi you have to be very careful lah. Later nanti bila you nak pre-process pun you have to relabel the string into numbers. Kenapa? Sebab kita nak calculate error. Right, so let's explore the data. So to explore the data, you boleh pakai shape ni for each of the samples that we have already preloaded, which is test images. So shape dia 60,000 kan. Ini test 10,000. Train image is 60,000. Okay. Train image dengan train label sama lah. Kalau 60,000 train, label dia pun mesti 60,000 juga. Okay, sama juga dengan test label, right? So train label tadi 10,000. So test label Train image 10,000, train test label pun 10,000. Right. So another way to check the number of samples is using length lah. Kalau saya print ada noise bagi tahu Right. So length will tell you the length of sample, right? Tetapi kalau shape ni dia terangkat penerangan shape tu dia lebih complex lah. So it also tells you how the samples looks like, right? So kalau the image ni test image, kalau saya sorry, tu tinggal. Okay. So I know that my image is 20 times 20 pixels. So I can go through yang ni semua tak ada masalah. Ni ada label je lah, nak tunjukkan label dia and so forth, right? So should be enough for you to understand. Okay. So the second part is to pre-process our data. So because we want to understand further the data that we have already loaded, alright? So kita akan gunakan matplotlib to plot the figure, right? And to show the image. So I am sure is a method to show image into the figure that we have already created. Right. So because the image is in train images, right? So let's say if I put 0, this is the first sample of the train images. So we have 0 to 60,000 sample. So kalau you nak sample yang ke 60,000 should be 59999. Should be this one. Ni adalah data sampel yang terakhir lah. Kalau yang 60,000 ni dah tak ada dah rasanya. Tak ada. Okay. So sampai sebab dia start dengan index 0. Alright. Okay, ni sampel yang ketujuh lah. Okay, so sekejap Right. So apa mana tadi? Alright. So up until now faham tak? Can you understand?
Still a bit fuzzy, sir.
Okay, dekat mana fuzzy tu?
Need to revise again after this, I think.
Okay, tak apa. So let me finish first and then we discuss again, alright?
Alright.
Don't worry. So nanti hari esok pun kita akan discuss benda yang lebih kurang sama je lah. So I will still use the same example, but probably I'll change the data so that you can see how the program works. Alright. Okay. So next, apa tu? Because the image, okay, dia kata kat sini the image is a pixel value from 0 to 255, right? So in order for the data to be loaded into an image like this, each of the pixel value is actually a number between 0 to 155. So a different number will point to different color. Okay, kalau saya tunjuk kat sini kan. Macam let me change. Send a tab. Mana ni? No, not tab. Cancel. Present a window. Okay. Kalau you tengok dekat sini, saya pakai pin ni kan. Perasan tak ni? Nampak tak? Can you see the edit color option ni? The color palette?
Nampak sih.
Okay. Tengok bahagian yang sebelah sini, yang grayscale ni. So a grayscale value is actually from 0. Kalau saya turunkan ni kan, arrow ni, all red, green and blue will have the same value. As I go through, kan bila saya naik ni, saya naik ni, all will have the same value and color dia dekat sini dia tunjuk. Okay. If I increase until 255, which is white, okay, all 0 is black. Okay, they consist of value between 0 to 255. So we call this grayscale, right? Okay, so balik semula pada contoh tadi tu. Kita okay, this one. Alright, so imagine each of the pixel carries one number, alright, which is in the range of 0 to 255. So we call this image grayscale image. Okay, although the image is black and white, sini nampak black and white, tapi dia bukannya black and white. Dia kalau black and white kita panggil binary image, right? So binary image will only have the value of 0 and 1, true and false, right? Tetapi for grayscale, right, you have a gradient of value from 0 to 255 for each image. Yang ini banyak tau, yang ini adalah sampel yang sekali banyak lah. Tetapi sampel yang kita loadkan ke dalam train images ada 60,000 samples. For each sample, we have an image that is consisted of 28 times 28 pixels that will form this image in grayscale, right? Okay, tak apa, don't worry. So next, kalau you remember, before we went to our holiday, there's one example of that I've given to you, which is the fruit dataset, kan? Saya ada bagi. So inside that example, there's one part where we would want to make our input consistent, because ada input yang range dia terlalu kecil, ada range dia terlalu besar. So if the input range is too high, it will impact the activation of the neural network, because the calculation of activation is summation of input times weight, kan? Kalau you remember lagi lah, input times weight. So imagine if your input is 255, kan? Imagine you ambil lah calculator kat handphone you, kat tangan you. Cuba try that 255. Kalau you punya weight you 0.1, so darab 0.1, you akan dapat nilai 25. Okay, so 25 is the first input times weight. So kita ada banyak input. Input kita ada 700 over, kan, 784 if I'm not mistaken tadi tu. So ini adalah activation yang pertama untuk neuron yang pertama. Imagine if you have 700 input, okay, 700 input times the number of hidden neuron that you have already set up. So kalau you set up hidden neuron you 100 pun, you bayangkan nilai activation yang besar tadi 25, you add up to 100, you will get a very high activation, right? Betul tak? And a higher activation will actually impair the training process. Training you nanti jadi haywire. So we don't want that, right? So the reason why we do the scaling, because we want to reduce the activation. Okay, so how to do that? Because we already know the highest value of the pixel is 255. So immediately we are able to divide with 255. So if let's say nilai dia kosong, kan, 0 divide by 25 jadi berapa?
Kosong.
Yes, jadi kosong. How about the maximum value 255 divide by 255, you get
1.
1. So by doing this, you will get a range of 0 to 1. So in between dia dapatlah in between 0 to 1. Okay. Kalau yang kat tengah-tengah ni dapat 0.5. Okay. So what we are doing here is actually called massaging, right? Massaging the data. So ataupun scaling lah. Right. So we do this. So this one is done. So we do this for both train image and test images. Right. So next, To verify the data is the correct format, we try and display 25 first 25 image. So first 25 image saya dah ubah dekat sini 25. Sebab you dah belajar Python kan. So by now you should be able to apa tu yang even yang awal-awal pun dia 10 kali 10. Yang ini adalah 3 size. Okay. Kita dah belajar kan Matplot library. Did you learn Matplot library?
Belajar tapi sikit.
Tak apa. Sebab yang student yang saya ajar pun tak apa, don't worry, saya tunjuk. Right. So in order for you to understand further, okay, saya tunjuklah. Boleh pergi dekat matplotlib.org kan. Okay, dekat matplotlib.org ni, have you gone through this website? Pernah pergi website ni?
Yeah.
Kan. So dekat website ni dia dah ada example dan juga tutorial. Okay. Example dia very straightforward. You pergi kat example ni, you boleh dah copy and then paste je dekat you punya example tu. You should be able to run the example lah ataupun tutorial. Very straightforward. Right, tapi kalau you nak nak go through one by one, then you have to go to the usage guide. And dekat usage guide ni, kalau you tak payah pergi semua sebenarnya, you dapat sikit je awal-awal ni, you should understand how to use it. Right? So dia beritahu macam mana nak import. It uses both matplotlib and NumPy. Okay. And then it uses list. Okay, sepatutnya you dah belajar list for the plotting of the data. And then dia dah ada dah. Okay. Parts of the figure. Yang ini apa? Ini title, read, legend and all. So all these have already they have created some sort of module for you, right? So PLT is the object. Yang kita dah load kat atas tadi tu kan. Import matplot library as PLT. So PLT is an object dot figure. So this object creates another object here. Pick ni. So ni akan jadi satu objek lagi lah. So lepas tu dia jadi empty. Kalau you run ni dia akan keluar empty figure. Okay. Then you run the next one. Subplot. Baru dia ada access. And then you run another one. And then baru dia bagi grid. Grid of 2 by 2. So if you do this one by one, you should understand how to use method library. Right? So yang ini dia lagi advanced sikit lah. So if you have already gone through this, at least one page of this, but you should understand how the code works. Alright? Let me continue with this. Okay, so yang ini boleh agak lah you tengok code ni. Okay, you keep the size 10 by 10. So kalau you nak besarkan, it's 20 by 20. Right? So this is the size of the figure. And then this is the range of the item yang kita nak iterate through the figure. So contoh yang asal ni 25 image. Tapi saya nak reduce, saya boleh image saya 9. So 3 by 3 lah. Okay. Things like that. So you boleh ubah code you so that you can go through the sample. Right. So yang ini dia sample dengan label sekali lah. Ini dia ada label dia plot label. Right. So the image is plotted with the labels. Alright. Okay. Now, next one. Tadi tu adalah berkisar tentang kita punya data, the sample, the how we manage our dataset, which is the fashion analysis dataset lah. So now I want to run my model, or I want to build my model. Baru dia nak build. Tadi tu baru kita main-main dengan data. Kita tak set up lagi kita punya build, right? Okay, so let's run the first one. So I've renamed kalau you ambil contoh tu dia model equals to tf.keras ni. Tapi saya buat run 01 sebab I want to run again and again. I want to run as many time as I want. So I create my own model. And then yang ini, kalau tak silap saya, dia rendah sikit, 128 kan nilai dia. Alright. So this is the input layer. This is the output layer. And this is the hidden layer. Hidden layer sama je. Hidden layer is up to you. You yang nak buat. Right? So yang 28 times 28 ni dia flatten lah. Okay, flatten dia jadi 700 lebih, 784. Okay. And then when I run this, so my layer, the initialization of my layer is created. Alright. So boleh tak sama? Boleh. Yang ini tak ada dalam contoh, dalam yang download tu lah. Yang ni saya tambah. So summary is the summarization of your network architecture. Okay, now your network architecture ni, dia punya input layer dia ada 784 kan. Okay, imagine how many trainable parameter. So trainable parameter is the weights. Okay, kita kira sama-sama. 784 darab dengan 128. Berapa? Ambil kalkulator kira.
100,000.
352.
Okay, 784 darab 128 100,000 352. Tapi trainable parameter dia dekat sini dia tulis 100,480 kan? Betul tak? Okay, so mana lagi selebihnya? Kita kira tak cukup ni. Kita kira 1,352. Tapi trainable parameter dia 100,480. Rasa-rasanya agak-agak je, tak apa. Kita nak tengok keupayaan berfikir you.
Your biases.
Yes, good. The bias. Alright. Imagine, bukan imagine, memang pun. Okay, this is the hidden layer. Right? So the hidden layer have 128 neurons, where each of the neurons has its own bias. So bila dia ada bias, dia ada threshold lah. Okay. So bias times threshold, so you have another 128 trainable parameters. So tadi tu 100,352 tambahkan dengan 128. So dapat tak nilai yang sama trainable parameter dia?
Dapat sir.
Okay. So that is the trainable parameter in between the input to the hidden neuron. Okay, now we have another connectionist kan. Connectionist yang seterusnya adalah dekat output neuron, which is the 10 neuron here from 128 to the 10 output neuron. So 128 times 10, you got 1,280 plus 10 biases, alright? You get 1,290. So campurkan kedua-dua ni, the total trainable parameter is 101,770. Yang ini yang kita create. So this is initialization. Alright. The next one. Boleh yang tadi? Okay, are you okay? Any question?
No questions.
No questions. Apa tu, kalau you ada confused ke, you need some clarification, so don't hesitate to ask me during my lecture session. Alright, tak apa, you boleh interrupt. Saya okay je. Right? Takut ada yang tak faham kan. Kalau tak faham janganlah senyap. Okay. Saya cakap laju je macam shot sendiri kat seorang-seorang. You can always interrupt me. Right? Okay. So next, tadi tu kita dah create initialization of our model. So now is the time where we want to compile our model. Tadi tu layer dia dah siap dah, tapi in order for us to run the training, kita kena compilekan dulu dengan optimizer apa yang kita nak pakai, loss function apa kita nak pakai, dan juga matrix apa yang kita pakai. So these are the training parameters. Right, training parameter ni ada banyak, optimizer ada banyak, matrix ada banyak, even how would we calculate our loss pun ada banyak cara. So this is one of it. Okay, you can immediately use this. Kalau you nak tahu optimizer yang lain, you boleh tengok nanti later we check, or we can do it together tomorrow. Alright. So nama model mesti sama tadi, model run 01. Okay, so saya run ni. So now my model is compiled and ready. Okay. Yang ini nanti dulu, yang ini tak wujud lagi. So I'll just leave it there. So now to feed the model. Ini saya semalam saya dah run ni. So I'm running model 01. Okay, and then dia punya history dia saya add up to another variable. Nama dia model 01. Yang ni lain tau. Model run 01 ni is the model itself. Model 01 ni adalah history dia. Jadi dia memang macam ni. So whenever you feed a model, dia akan return dia punya history as is. You boleh je run macam ni, tak payah you buang ni pun boleh. Tapi saya nak tahu dia punya history dia. So I create another variable, so the history is loaded here lah. Model 01. Yang ni pun tak ada dalam tutorial tu, sebab tutorial tu dia adalah beginner. Yang ni saya explain kat you, saya terus tambah lagi sikit lah. Right, so ada juga saya tambah batch size. Right, so the batch size by default, I'm not sure the default batch size tu berapa, tapi kalau you run by default dia sikit je lah batch size dia. Okay, kita tengok. Okay, let me run this first for 10 epoch. Nampak tak, dia punya sample dia cuma ambil 20,000 saja, where our number of sample is 60,000 for training kan. Tapi dia tak ambil semua, dia ambil 2,000 saja sebab saya pilih batch size saya 30. So kalau you bahagikan 60,000 sample divide by 30, you'll get 2,000 lah. Okay, so 2,000 is the batch size, right? So saya run. So this is training. Okay, train sebab saya pakai train image. Alright, so it's quite fast. Alright, where it train 2,000 image ni kira laju lah ni. Okay, tapi kalau saya decrease the batch size, dia akan jadi a bit more slower, right? Okay, it's going to finish. Right, habis. Very fast, right? So sekarang saya nak tunjukkan kalau batch size tu saya nak simpan sebab saya dah run model 01 ni. So I want to keep that because I want to run again. So batch size ni kalau saya jadikan dia satu, dia akan train all 60,000 sample. Macam nampak tak? Tapi in order for me to train all 60,000, it will take more time. Alright. So saya stop dulu yang ni. Okay. Tak nak stop. Dia degil tak nak stop sebab ni kot. Dia SRF. Tak tu lah. So interrupt je. Kita nak begitu. Kita ni stop pun tak nak. Kita ni beratas. Okay. Shut down. Bila I shut down, I have to restart from earlier. Right, tak apa, no problem. Restart and clear. Tak nak confuse. So yang ni saya adakan balik 01. Sekejap saya run yang penting-penting je. So yang ini penting kan. Kena error. Sekejap Okay, tak apa, sekejap. Let me stop this first. Sebab kena error. So I need to shut down here. So don't worry about this. Dia kalau ada masalah macam ni kan, you can always fix it. So don't worry about it. Of course it's a bit taskful lah kan. Leceh nak kena. So saya kena tutup environment saya sebab dia tak nak. Okay, saya rasa saya tahu kenapa. Sebab saya terbuka dekat browser lagi satu. Ada dua browser running same server. So dia buka ada same file. Tak apa, delete. Okay, hold on. Kita rehat sekejap. While waiting for me to Peter untuk. Have you tried the doodle hari tu? Did you have fun with the doodle example?
Yes.
You can let your family try it. Kalau ada adik-beradik ke saudara mara kawan-kawan kan yang tak ada dalam kelas saya, suruh dia orang try. Let them have the same fun that you did. Okay, sekejap. Okay, supposedly I should share this one. Tab. Alright. Okay. Okay, yang penting kita kena run ni. Ini. Okay. Lepas tu kita kena load data. Lepas tu kita kena label penting. Yang ni explore data ni tak payah. Explore data ni tadi masa saya explain tadi. Okay, lepas tu set up layer ni penting. So set up layer saya tak nak besar sangat. Saya nak 128. Alright. So, ni run 1. Tak save tadi. Run 1. Okay. Ada dah run 1. Okay, run 1 juga ni. Tak ada ubah apa-apa optimizer dia. Lepas tu yang tu saya biarkan dulu. Okay, lepas tu saya boleh. Okay. I'll probably create a smaller batch. Alright. Smaller batch size. So I increase jadi 40. Sebab saya nak dia train lagi laju. So kita tengok lah. So different model, different run. Kita tengok. Nampak tak dia sekarang dia punya sample dia masih sikit sebab batch size dia increase kan. So wait a bit.
Sir, if we set a low batch size, does that mean we will get a better accuracy?
Good question. Alright. Hypothetically, you should get a better accuracy. Hypothetically, right? Because you are exposed. The model is exposed to more sample. It should generalize better lah. Provided, okay, jadi syarat dia. Provided that we also have a sufficient number of epoch. Kalau you punya batch size you decrease kan, if I decrease my batch size, it is exposed to a more variety of sample, betul tak? Sebab sample dia besar kan. Tapi epoch dia pula macam mana? Is a smaller epoch sufficient for our training? Tak apa. You'll see that, right? So that's why I create macam ni supaya kita boleh run banyak kali and then we can compare. The idea for this exercise is later you understand how to use TensorFlow and then you are able to compare the model. Kita nak buat macam tu. right? So next up would be yang ni saya dah train. Next up would be yang ini. So this is also, yang ini pun tak ada juga dekat dalam yang downloadable punya example tu. Yang ini adalah code yang saya dah edit, where you can actually plot the accuracy and the loss. Nampak tak? Accuracy. Sekejap. Ini loss sebenarnya. Loss. So accuracy dia semakin menaik kan? Untuk training Okay. Dan loss ni semakin menurun untuk training. So we should have a very low loss lah if we want to have a good generalization of our model. Okay, I'm getting back to your question tadi tu, which is a good question, and I'm actually getting at it, right? What if I change the batch size? Okay, so these are the variable that we can consider in order to create or to find a good machine learning model. So machine learning model ni banyak jenis kan. So remember yang contoh yang fruit dataset yang saya bagi dalam contoh yang lepas. So kita ada banyak model. And in that example, we compare the model. Kan kita compare decision tree, lepas tu kita compare SVM, kita compare random forest, right? So we have many kind of algorithm with the same sample of dataset and probably the same number of epoch, right? We train between the model and then we try to give a conclusion which model is the best model. Right, yang itu contoh yang sebelum ni. Okay, so the experiment was created so that we can find out which model is the best for the data. Okay, tapi untuk contoh yang ini, there are a lot of parameter that we can look into. Okay, one parameter we can look into which is the batch size. Okay, you boleh create you punya hypothesis sendiri. Sebelum ni pun you dah pernah buat experimental setup kan? Did you all take physics masa kat sekolah?
Ambil.
Long time ago, sir.
Tak apa. Even science pun dia ada explanation kan. You pakai radar apa. Before you create your experiment kan. Apa tu, how many especially fizik lah. Fizik ni dia lebih apa tu fizik dengan chemistry. Dia very apa tu related to mathematics, right? So you kena sukat. You have to measure your sample before you run your experiment so that you know which measurement of samples will affect the outcome of your experiment. Sebab different measurement of sample will give different outcome, kan, betul tak? Sama jugalah macam ni. So outcome kita apa? Outcome kita adalah the accuracy. Our goal is to get a high accuracy, because high accuracy means that our model is able to classify the output correctly, kan, betul tak? But what are the parameters that affect the accuracy? So parameter dia macam ni lah. Epoch, batch size, probably the optimizer. Okay, the optimizer can also have an effect to your to your training. Or can it be your activation function? Activation function pun boleh tukar. Yang ini kita pakai ReLU. Okay. Macam mana you nak tahu how ReLU works, you can Google it up. Okay. It's an activation function. It's a mathematical calculation. You can also change this to sigmoid. Boleh juga ubah. Yang ini kita tak pakai sigmoid, kita pakai ReLU. You boleh pakai hyperbolic tangent. Alright. And even the number of neuron can be changed in order for you to have a different result, right? So let's try it out, right? Kita nak try out Okay, soalan you tadi semalam saya dengan kelas yang sebelum ni saya ubah neuron. Okay, maknanya number of neuron ni saya ubah jadi 100 daripada 128 saya ubah jadi 400. And then kita nak compare hipotesis kita apa akan berlaku kalau number of hidden neuron berubah. Okay, a higher hidden neuron should increase the accuracy. That was the hypothesis. Tapi bila kita dah run eksperimen, sebenarnya tak. Neuron bertambah untuk nilai epoch yang 10 kecil tadi tu, dia performance is lesser. Maknanya performance dia tak berapa bagus. Walaupun neuron dia tinggi, tapi mungkin because of the small epoch at 10, the network did not have enough time to learn. So dia punya accuracy dia rendah. So pertanyaan you tadi batch size kan? So saya pun tak tahu because we haven't done the experiment yet. So let's try it out. Okay, so kita try juga. I'm using the same model. Model saya tak ubah sebab I'm using parameter yang sama, tapi saya nak ubah batch size. So saya tak payah create model baru, tapi run yang berbeza. So run berbeza, saya buat model. So I hope everybody understand. Model 02 is the same model tetapi run berbeza. Right, so batch size saya kecil. So saya buat 20 batch size. Right, so bila batch size kecil, number of sample bertambah. Right, so saya run. Okay, see now earlier on I have 1500 sample. So in this example I'm running with a bigger batch size lah. Batch size dia smaller, a bigger sample, right? So run. So kita nak tahu sama ada what will happen if the batch size sample ni is increase. Kalau sample ni increase, adakah dia akan jadi better ataupun sebaliknya. Okay, untuk number of epoch ni lah. Ini pun kita kena consider juga. Okay, so mungkin these are the parameter of the training that you should consider. So semester ni you kena buat mini project. Okay, so to make it easy for you to manage your project, so I would recommend you to use TensorFlow. Okay, you pakai je TensorFlow ni, tetapi the dataset you cari sendiri. Okay, selain daripada MNIST dan juga MNIST yang number ni dan juga fashion ni lah, and then you have to pull in several experimental setup. Macam ni, you nak train batch size dan esok lah saya explain ni. Okay, saya kena tunjukkan yang dulu. Okay, so sekarang saya dah ada plot yang kedua, which is the history untuk 01. Yang history ni, yang ni saya buat history tau. History ni sebenarnya dia datang kat sini. So saya boleh ada history untuk model 01 dan untuk model 02. Sepatutnya sebelum ni tak ada, tapi because saya dah run, dia dah ada lah. So kalau 01, history dia ada 10 epoch, ada 10 value ni. So 10 value ni adalah dia punya loss. Yang ini loss untuk model yang lagi satu. Right, so bila saya run dekat sini kan, saya plotkan this one. So I can also plot this one. Lepas tu legend dia, kalau tak silap saya, ini kot legend ni. Ini okay, bismillahirrahmanirrahim. See? Ni interesting. Kalau you tengok ni, Okey, ini adalah model 02. Yang warna orange ni. Yang warna biru ni yang awal-awal tadi lah. Sama, okay. So as you can see, for model 02, sampel dia besar kan? Betul tak? Okay, so dia punya accuracy dia awal-awal dah tinggi dah. Okay, awal-awal dah tinggi dah accuracy dia. Tetapi untuk yang 01 ni, accuracy dia rendah. Okay. There's a probability kenapa dia jadi macam ni sebab saya pakai model yang sama. So mungkin the load the previous trainable parameter, right? So that is happening lah sebab saya malas tadi kan nak create kan. So dia dah awal-awal dia dah tinggi dah. Dia punya training accuracy. Dia macam weight tu dia dah preloaded dengan a bit better value. However, as the epoch is increased, okay, a higher number of sample needs more epoch. Maknanya dia perlukan masa yang lebih tinggi untuk dapat accuracy yang tinggi. Sebab yang tadi tu, yang rendah ni accuracy dia lagi bagus. It perform better. Dekat sini dia dah berjaya lawan yang accuracy awal-awal ni accuracy tinggi tapi dia stays here. Dia tak naik. Tapi yang awal-awal punya eksperimen dia start with low accuracy, it increase and eventually it surpass the second experiment. Sama juga dengan loss dia ni. Nampak? Okay. So ini adalah untuk dua eksperimen. So I can show you several other experiment that I've done where I would run more than 2 experiment. Kita run banyak. Tapi kita tak boleh saja-saja je ubah parameter tu ikut sedap kita and then kita run. Sebab before we do our experimental setup, we have to create our own hypothesis, kan? Betul tak? So hypothesis you apa? What is your hypothesis? So from your hypothesis, barulah you try to run the example and find out whether your hypothesis is true or false. So contoh saya bagi hypothesis. Hypothesis saya adalah if the neuron is higher, okay, if the neuron at the hidden level is higher, the network will perform better. Itu contoh hypothesis saya lah. So in order for me to prove my hypothesis, I have to have an array of experiment that consisted of different number of neuron at the hidden layer. Okay, saya kena buat macam 20 sampel ke, for example, in order to prove my hypothesis. So maknanya ada sampel yang pertama, hidden neuron saya 100. Sampel yang kedua, hidden neuron saya 150. Sampel ketiga, hidden neuron saya 200. Lepas tu saya increase by 50. So saya ada 20 eksperimen with different hidden neuron. So if I run that, okay, I should see that my graph will show a higher activation or a higher accuracy as I increase my number of hidden neuron. So contohlah, saya tak run lagi eksperimen tu, so I wouldn't know, right? And different sample of dataset will also yield a different result. Maknanya kalau contoh fruit dataset yang kita belajar sebelum cuti hari tu, mungkin KNN is the best algorithm to solve that. Tetapi bila kita ubah the problem, okay, here for example the fashion MNIST dataset, probably KNN is not the best algorithm to solve it, or not. You won't know unless you have already created the experiment. Okay, so mini project ni nanti dia macam latihan sebelum you buat you punya FIP nantilah. Okay, so you should have some sort of hypothesis, and from your hypothesis you will do experiments, and from the experiments you would know how to prove your hypothesis. Okay, boleh ke saya macam mengarut seorang-seorang?
Will take time to absorb everything, sir.
Okay.
Sama lah saya.
Alright. Saya pun tak cakap the whole 2 hour kan, so that's the reason why I took only 1 hour to explain this to you, because I know of course you need time to understand. So kalau saya bagi full lecture for 2 hour, you pengsan nanti kan. Alright, so tak apa. So I'll just we have 2 minutes left, so I want to finish up. Right, so kita evaluate tadi tu adalah training saja. So now you also have to calculate the accuracy of the test, the test accuracy, right? So ada 2 kan, satu yang model 01, tak ada, sorry, saya ada satu je sebab saya model tu saya create satu je. So this is the test accuracy, and then if you run this, okay, dia akan predict lah. Bila kita masukkan image kita, dia boleh predict. So kalau prediction yang test image yang pertama, dia predict the highest activation is the classification. So bila kita pakai modul maximum ni, argument maximum ni, so dia akan return index yang paling maximum, which is 9. So maknanya classification dia 9 lah. Okay, so classification dia kalau kita ulang balik daripada awal tadi, from 0 to 9. Okay, so untuk label, kita check balik test label 0, so sama lah. So kalau prediction dia 9, test label dia 9, which is the same. So now the rest is how to match up the prediction and the label. Alright, so inilah function yang kat sini adalah function untuk match up label dan juga dia punya output activation dia. So ini back, dia identify as back. Yang ni contoh yang lain, kasut ni tadi kan, salah lah, wrong prediction, sandal. So kalau saya run yang awal-awal tadi tu, sandal ni kalau tak silap saya dia sepatutnya sandal tapi dia identify as kasut. Dia punya label dia mislabel, right? Tapi kalau saya run yang awal-awal example yang higher accuracy tu, dia boleh dia boleh identify ni sebagai kasut lah. Okay, yang ni dia identify sebagai sandal, which is wrong, right? So this is the multiple plotting, right? Okay. Ada yang salah, ada yang betul. Yang merah ni salah lah. Okay. Wrong classification. Right, so that's it. So yang bawah ni use train model ni nantilah esok saya explain. So up until now, kalau you boleh keluarkan output yang macam ini, you should have managed to create your own classification model. Alright, so that's it for today. Thank you very much. Just to tell you, saya ada masalah dengan attendance punya collection ni. Ada orang yang dia tak record sebab kalau dekat sini kita ada dalam, let me stop this one, dalam 28 orang kan, tapi dekat sini dia punya attendance dia ada 26. Never mind, so I'll just download this first and I'll try to fix the attendance system. Alright, so kenapa lah dia ada nama orang yang dia tak record, but I assume that everybody is here, right? Tak ada yang absent kan? So macam tally je dengan dalam group tu. So I think that's all for today. Thank you very much. And I'll meet you again tomorrow. Okay?
Okay,
Alright, thank
sir.
you,
Alright,
sir.
sir. Thank you. See you tomorrow.
Okay, have a
Thank you,
look at
sir. Take care.
have a look at the example. Okay, kalau you dah go through the example, kalau nak tanya soalan, please ask question tomorrow.
All right.
Okay.
Thank you,
Goodbye.
sir.
See you tomorrow.